starting. So, in the last lecture, in the last exercises, we have started with this array, with this custom array, and we have quite a few things which we need to add to it to make it a truly useful container class. So there are a few very simple things, like an operator that just gives us something at a given position. So this we can add very quickly. It is pretty much just a wrapper for the add function. What we could add, of course, to the add function would be some sort of failsafe. If we try to access an invalid offset, then it would throw an exception or return a dummy value. So in principle, both options are serviceable, but the exception is a more correct approach. It will cause a crash, or will of course you can catch the exception, but generally the idea is that it's better to crash in a defined way than to risk undefined behavior. And if we would return a dummy object, then the way this is made here, since we are returning a reference, such a dummy object, we probably would have only one, and then if multiple threads would want to get the dummy object, then you could have multiple threads using the same memory at the same time, which might not be what you want. In principle, of course, the array as is not thread safe anyways, but depending how the user operates, there might take a reference to this object and then unlock a lock which they used for accessing the array, which technically would not be a safe thing to do. So the risk of using such a shared dummy object is not very high. It would only manifest when people would do things they shouldn't be doing anyways. The standard template library of C++ by default expresses the behavior where it really just throws exceptions on such access attempts. For our use case, since we don't want to introduce new exceptions, classes, etc., I think we'll go with the with a less elegant approach of using a dummy object. This has one limitation. Still, the object must be something that we can in fact construct here. When you look on, for example, append, the way it works, we are always using the copy constructor. We are never using a constructor which would create something with no arguments. But for this dummy object, we need this. So this restricts slightly which types of types we can use as types for our array. But I think this is a reasonably simple approach. We can also have this dummy object exist on our helper class here. So we just add here a t dummy, which will be created once the thing is instantiated, and here we will add a test. So if index is greater or equals where's our get size here? Get size. Then return dummy. Okay. Although this requires m to at least be allocated, so it might still fail. We could make it even simpler and just define dummy on our own object. That would be a bit more fail-safe, although it's not really elegant. We can later on, of course, look into creating an own exception class and use it instead. But generally, since accessing indices at invalid offsets is one of the most common error sources when using arrays, it's really recommended to have at least some way to mitigate such an access, even in the simplest implementation. The other case is like appending things. This would only fail if we fail to allocate memory, which on modern systems is not very likely. Not impossible, of course, but usually you just start paging out memory to the disk more and more, and things get slower, but you will not get a out of memory. In principle, on 32-bit systems, which still were paging out things to disk, the major limitation was the available address space. So you could, after you allocated 2 gigabytes of something, you would run into just not having enough address space, even though in principle the computer could still page out more memory to disk. So then you would also get a not enough memory exception, or an allocation failure. Iterators is something. Okay, so let's continue to the next things that one might want to add to a array. So the standard template library, for example, on its own array as well as its own other container types, is using something called an iterator, which is in principle a reference to a entry inside the array, which can be advanced forwards and backwards. Technically, it only needs to be advanceable forwards. Advancing backwards is something that you could implement, but it's often not implemented. And with an array, as we have here, this of course is kind of rather little use, because the array as we have it here, we can just access it by offset. So we just run a loop from 0 to 1 less than size, and then we can access any element, and this is fast. But if you would have other data types, their other container types, their access by index is not something that really is part of their architecture. For example, a linked list, there you only know the first and the last element in the list, and the elements are pointing on the next or previous element. So if you want to go to an offset, you would always start at one of the ends and then go through the whole list until you performed enough jumps to arrive at the index you are trying to retrieve. So that would be quite inefficient. But you would still want to be able to traverse such container types, and this can be done quite easily with an iterator, because it's more complex than just an index. So it will just contain an internal pointer to the current node, and then you can just advance easily to the next and previous nodes, etc. Other container types where such iterators would be very useful are maps or hash tables. A map is basically a binary tree, so there you also don't have a order in the sense that you could access it by an index. There is an internal order how the elements are stored, but this accessing it by index would still require traversing at least half of the structure on average to find what you are looking for, so that would be also inefficient. For our array use case, the iterator is a very nice demonstration of how to implement it, because it's extra simple. If we would have something that is more complex in structure, then the iterator itself would also become more complicated, and thus it would maybe not demonstrate like the very basic principles in such a direct way. So I'll quickly implement also an iterator mechanism here. So an iterator, of course, is an own type, so struct as iterator. We can so of course we could give it any name we want, but it's a set. If it's an iterator, then we just should call it like this. And the basic functions to handle with iterators will be just want to get an iterator that points to the begin of our array, and then we will also want an iterator that will represent the value of an iterator once the end of the array has been reached. So it's called end, but the end is like not the last element in the array, it's like the element after the last element, kind of. So you cannot dereference an iterator that is pointing to end. You can only use end to compare. So if you have an iterator and you advance the next position, you then compare it with end to see if it's still valid, or if it's AND, then it's already not valid. If one would want to be able to iterate backwards through a container, then the recommended approach would be to create just a reverse iterator. So basically like the normal iterator, just one that goes the opposite way, and then you would have like R begin and R end to retrieve those reverse iterators, which by the way will be the one of the, or maybe the only homework for today. We will see how far this process progresses. What's the date? 27/11/2025. To the array back to front, and my recommendation for this would be to just modify the existing iterator, probably with just an additional parameter, not like create it again from scratch. But that will be up to you. Okay, so let's start. So the iterator, we of course will want something to be able just to create it without any arguments. Might be useful in certain cases, so we create such a empty constructor. But then, more important, we will want to have a constructor that allows us to create an iterator for our use case. So as struct, as you might remember, by default everything is public, so we don't need to add here anything. This can be accessed by anyone, but we'll make something protected, and here create our protected iterator. So what was the name? CRA. So we don't want some of the iterator's functionality to be accessible to anything but our own C array. So this thing will take a pointer on the current array. Array, and it will take an index, which by default will be 0. So that we could in principle create an iterator at any position. For example, we might want to add later a find function, and when creating this find function we have the liberty to determine whether it is find that returns an index or a find that returns the iterator. Since we only can have one function with the name find, if the arguments are the same, we cannot differentiate by the return value. The standard approach would be here to be find for getting an iterator and index of for getting the index of something. And such an index of is meaningful in the context of an array, as this allows random access, but in the context of a map or tree or even just a linked list, an index of is more or less pointless, because there are just no indexes. So there you would always only have find, and then once you find something or not, then you have your iterator. And the way this find works is quite simple. It either returns you a valid iterator, or it returns you an iterator which, when compared to AND, will yield true. So let's proceed with our implementation. So of course the iterator needs to know the array it belongs to, and it needs the index if one was set. Index index is equal to 0, and here we just set array is equals array, uindex is equals uindex. As simple as it gets. We can make this a bit more compact just so it is nicer to read. And at this point we already can populate these two functions, return iterator, and of course how we do this explicitly is up to us. We could be more or less fancy about it, but a simple approach is just to have this work like this, and get size, and voila. We could also, for example, define that AND is something if we would have just passed null instead of a valid array. But it's generally recommended to always have a reference to the object an iterator belongs to. Because if you would want to add more safeguards, more exceptions, etc., then, for example, you would want to ensure that nowhere in your code you are comparing an iterator from one structure, from one container, with an iterator from another container, because this is never a valid operation. You always compare iterators returned by the same container, and if you would have code that would, for some reason, if you are comparing with AND, work fine, it still would not be recommended, and your compare function could have such a test which simply checks whether the thing is belongs to the same array. We might not add this here, but it's just good to know that such things in a more feature complete iterator would be to be expected. Okay, so what we of course will need is another constructor, one that allows us to copy things, so that we can copy assign one iterator to another iterator. And we will also have an assignment operator, so here we will just exploit that. This equals, and now we just proceed to the assignment operator. Reference operator equals, it takes the same arguments, of course. And here we just assign the two things similarly to here, just that we take them from other dot other suck more and return asterisk this, as it's customary for assignment type operators. Okay, so at this point we can create it, we can copy it around and move it around. So next thing we would of course want is to get something from one of the operators, so somehow access the data that is stored inside. For this we will use another operator. So we can implement a error operator, which is usually quite useful if our type is some sort of object. We might of course I think STL does not have an error operator like this. They always expect you to get the value. Is that so? No, I think they have as well. They certainly have this as well. I think Qt doesn't have. Qt always has slot value, but that doesn't matter. For us, we just want it to be convenient, so we create such a operator which will then just return array array of course this needs to be a reference array at mu index. So this is quite simple. We are just using the existing add function to get it at the index. Of course, if we would have a list or something else, then this would be much more complex. But as said, this is to be here just to demonstrate the very basic principles. And there is a second operator we also would want to have, the asterisk operator, which just gives us wait, do we need that this and this should be by reference, so this should be with no reference, yeah, like this. So they are always using this add, and if we would have an invalid index, this would also here return a dummy, or if we would add exceptions, throw an exception. So next things we of course want is we want to check whether such an iterator is actually valid, so to be able to compare it with the end iterator value, we just implement a compare operation. It takes again just an other as an argument, and it's as simple as gets, return array. It must be equals other array, and it must also have the same index value. And then just for convenience we could also add a non-equals operator. This can be either added through negation of the previous one or just explicitly implementing this, and for just a few options this is the more convenient approach. Okay, and last things we need will be something to advance the iterator. So I said we want to be able to move to the next element, so this will be a operator, just the plus plus operator, plus plus. And when using plus plus, you have, as you might remember in C++, two different versions. You can have plus plus variable name or variable name plus plus. The difference is the first one, plus plus variable name, increments and gives you the incremented value, while variable name plus plus does the incrementation but gives you the value as it was before it got incremented. So since the operator plus plus here, the way it's defined, it's kind of not really differentiate between these two cases. The way this simply works is that the plus plus is this one, and if you want the other behavior, so first of course we do this one, index plus plus tone asterisk this. So for the other approach, they just added an int e argument, a dummy, just so that they are different. And then in this case, of course, we need to create a copy of what was before. So alt is equals asterisk this. Then we increment, and then we return old. And this is now already complete. So I said it is quite simple. So we will want to create a test case for this. I think we should have here some split or reduce. Yeah, so we have, for example, here are crumbs, and here we are printing them using the add function. So what we could do is we could just first of all we would want to add a end line so that the things don't get confused, and another end line, and now we just use an iterator to do more or less the same thing. So auto e is equals crumbs punct begin is not equals crumbs punct end plus I, and here we'll just use asterisk I. This is a string, so if this is a string, then we'll use the arrow operator. If it would be something that the thing can print, we could have used asterisk, but in this case, of course, there is a semicolon missing here. Okay, and maybe let's just comment this, or just add here another line. And let's oh, that should be u index. I think this arrow might be in a few more places, and with the array without p. I think I used p almost everywhere. Not really. Okay, so just let's correct this here. And this more typo. Okay, and using iterators, as you see, it yields the same result as before. So this works. And there is another thing you can do with iterators. I think how was it for auto crumbs. We called it value c string. And forgot this. So here using range loops, it's again the same. So in this case, this is quite an explicit approach. So we are still using auto to get the type for the iterator, but we have our begin, our end, our plus plus, so we have to type a bit. With the range loops, this thing will pretty much do it this exact same thing as here, but this is abstracted away. So we need just to write what variable name do we want and from which container we want the elements to be iterated through, and the loop will and the compiler will implement the loop for us. So if we put a breakpoint here and run the code, we will see when we go here that when we enter thingies that we are in fact arriving at the begin, and then the whole rest will still keep being executed. So we assign, we return, then we get the value for end. Then once we're done with that, we exit this, then we make a comparison, then we are getting the value. So it really does everything for us. It's quite convenient. And I think creating a reverse iterator or making this iterator reversible by adding a second parameter which will just change the direction in which it will iterate is, I think, quite a simple task. Okay, so we need something to do now, and as we see here, we are still missing a few things. So we need off as well. So there are a few things we could add. We could add a find or rfind. We could add the index of or the substring. So since we want to keep things maybe within the theme of our iterators, then let's go for implementing a find. It takes a const t reference what, and basically it just goes through the array. It does a comparison, and when it finds a match that t is equals the value inside the that what is equals the value inside the array, it returns an iterator pointing there, which with this syntax can be done pretty easily. We just, instead of size t, specify a valid offset inside the array. So who would like to implement this find function? Actually, we should move it here maybe. Oops. No volunteers. Okay. So who should we take? Maybe Mr. Sefer? Mr. Sefer Poladi? Would you like to implement it? Okay, sure. Mm-hmm. We already have a find, but defined. You don't need to write the function definition again. You don't need to write the function definition again, it's already defined, and we don't return size t. We want to return an iterator. So what you need to do is you need to just inside the function which already has been defined in line 120 create a loop that loops from 0 to size, and then compares inside the loop's body the value of our array at the position of the iterate of I of your loop variable to the what the argument, and if it matches then it just returns I, and if fails and so it doesn't return the 9, it returns an iterator from this and I, and if it fails so if the loop doesn't find anything after the loop, you just return end. You can delete line 122. This is not required. You just need to start with the loop. Yes. Um, that is not all quite right. So first of all, get size is written with a capital G and capital S. Secondly, we don't have a start argument, so you can just start I with 0. And lastly, we want to return iterators and not indices. You need to return an iterator object. So you need to write as iterator, open bracket, this, comma, I, close bracket, semicolon. Just return as iterator, open bracket, this, comma, I, close bracket. Okay, we need a semicolon at the end, and the S in S iterator is capital. Okay, then we need a semicolon at the end. After the closing bracket. Okay. Then we will need a return in the functions body after the loop that just returns end in case the loop hasn't found any matches. Okay. Next thing, we do not have a start um, argument, so either start at 0 or add start you start to the argument list in line 120. Okay, and then there are quite a few capitalization errors. So get size has a capital G and capital S. You start in line 125 has a capital S. Get size in line 122. G and S are capital. Size T is small, just U size needs a large S. You start, yeah, and in the line 122, the function get size has a capital G and capital S. Okay. And last issue, in line 126, you don't compare to, you already changed to value. Okay, so that's fine. Then it should work. So now we need to create a test case inside main CPP to see if it works. You could use the crumbs array and search for something on it and see what you get. you should add the test code inside the main function, not after the main function. For example, somewhere in line 98 or something around that area. You could make it quite simple. For example, just autof is equals crumps dot find, and then as string just use user. Okay, so our array is called crumps, not just arr. Secondly, endle is with an L and not end one. Okay. the array, the name of the variable is not ARR, but crumbs, like defined in line 81. Okay, then we are searching for a string, so not find 20, but find, for example, quotation mark user quotation mark. Still line 98. The argument for find needs to be a string. So as an argument, you could, for example, specify quotation mark user quotation mark with a capital U. That should give us the third entry in the array. Yeah, crumbs.find, open brackets, quotation mark, users, or user, a second quotation mark, and close bracket. Now the double quotation marks were the right ones. Yeah, you just need to write user with a capital U as a string inside the brackets. User, yeah, capital U. And then in line 99, you also need to change the variable name. The name of the variable in the comparison should be crumbs and not ARR. Okay, and last thing, you have asterisk it. You need the asterisk arrow C string. So remove the asterisk before the it. The end line was correct. It's the expression before it which is still in need of improvement. No, that was fine. That was just std end line. That was okay. In line 101, you need to add the std again, which you have removed, because that was fine. Before double point endl. yeah, before double point, for the first double point, add just std. Okay, and what needs to be improved is the asterisk it expression. Remove the asterisk. And then use the arrow operator to access c underscore str on the it variable. You need first the asterisk, the arrow operator, the dash greater than. Nope. Look on line 90. Just that there is just an I. In your case, it would be it arrow c underscore str brackets. Just add a arrow operator, the dash greater than, at the position of your current cursor. Just press dash on the keyboard and the greater than symbol. If it's a German keyboard, then dash is next to the right shift. It's the minus symbol. No, almost. Don't press shift, just a dash. Yeah, and then the greater than, it's next to the left hand shift. Yeah, just one. No, just one character. One greater than. You have two greater thans. And then c underscore. C. Yeah, it already suggests. It is suggesting you already in. Yeah, this one. Click. And now open and close bracket. Okay. Okay, let me have the mouse. I'll run it to see if it's working. We also don't need the return here. Okay, let's run. Okay, here we have another mistake. This should be then, of course, also end. Okay, let it run again. And what did it say? It found user. It's working. Good. Okay, so according to the bureaucracy, we need to do a evaluation of the exercises. So you should have gotten an email from this system today. And then I guess it will have a link to some online inquiry or something like that. So you can use the remaining 25 minutes of the exercises to fill this out and let me know when you are done. So if you are done quickly, then we can do something more. And if not, then that was it for today, for the exercises today. Have you got the email? Can someone give me a confirmation that this worked? Perfect. Then let's fill it out.